Okay, click and close for a second. I want to just go through a couple things I see happening here with you. We get right back to this. This won't take but a second. So one thing is on the first practice for the 2.1 practice 1, I get why people are maybe confused by this function, right? I'm going to change this function so it wobbles back and forth more times so you can see that it's a pattern. Because I think maybe what people are thinking is, well, what happens over here? Does it keep going up, you know? And it doesn't. It's just, this is what we call a sine function. You'll see later on in math. It's just going to keep going. It's like a wave. It just keeps the same, going to the same amplitude, goes up to the same height and the same depth, right, each time when it wobbles. So that's the highest point the ant could ever go, and that's the lowest point the ant could ever go. Does that make sense? And like I say, I'll fix that so you can see more cycles of that so you can see that it's a pattern. Okay, so here's something I want you to know about, though, because this is, people have troubles with this, and it's a really easy fix, but I want to demonstrate something for you. If I take like a Desmos calculator, let's just take the Desmos scientific calculator, for example. And if I want to do something like this, what if I want to do -3 squared? What's -3 squared? 9? Everybody agree? Okay, let's try that. So if I try something like -3 squared, watch what Desmos tells me. -3 squared tells me -9. What's wrong? -3 squared is 9, isn't it? -3 times -3 is 9. What did I do wrong?
You forgot the parentheses.
Forgot the parentheses. You see, you have to have parentheses around this. If I don't have parentheses, calculators are smart. They know what order of operations is. They know that I should do exponents before I multiply, right? When I've got a negative out in front of something, doesn't it just mean -1 times that? The coefficient here, like if I wrote something down, like for example, if I wrote down -x squared, what's the coefficient of x squared? What's the number out front? -1, right? What am I doing? I'm multiplying -1 times x squared, right? So when I have -3 squared, -1 is the coefficient of 3 squared, but by order of operations, what do I have to do first? I've got to do exponents first. So the first step is going to be I get -9. I multiply the -1 times 9. If I want to actually square out the number -3, I have to put the number in parentheses, and I'll demonstrate that. Like if I do that on Desmos, watch what happens. So if I go down here and I put in parentheses -3, and I square it, now that gives me what I'm supposed to get. Right, then I get 9. So there's a moral to the story. Anytime you're ever taking, two really important things come out of this. Anytime you take any negative number to a power, first of all, you got to always put the negative number in parentheses, right? So that's just a general rule that's always going to be true. Let me take a picture of this real quick for our notes. Okay, but that has some other ramifications. When we're doing stuff like that, I'm doing something like that, evaluating functions. Now let's just briefly review the stuff just for a second that we talked about yesterday. If I focus just on the function part of here, don't worry about anything below that. What's my input variable? Just on the top line there, f of x equals the absolute value of 3x minus 2x. And I'm going to make that, tell you what, let me make that, where's that? I want to make that squared. What variable am I inputting? Well, okay, but don't think about, I'm just like, ignore that line, in the top one, what's my input variable?
Okay.
X, right? So X equals the input. What's the output?
F of X?
F of X, right? F of X is the output. So down here in this line right here, what am I inputting? -8. I'm inputting the number -8, right? And so F of -8 is going to be my output number. It's just a number, right? So if we start off here with F of X equals the absolute value of 3x minus 2x squared, here's my best advice to you. When you're going to want to input some number, the first thing you should do is don't even bother with the number. Every place when you're going to evaluate a function, every place where you have an input variable, an x, we're just going to replace that with an empty quantity, an empty set of parentheses. And think about that like a jar I'm just going to dump the number into, right? When I actually do plug the numbers in. But put it in parentheses and then you'll never make mistakes evaluating functions. So I get 3 times whatever, my number, minus 2 times my number squared, right? And so if my number is a -8, that's the number that I'm dumping into the jars. I'm dumping into the variable x. Does that make sense? I'm plugging that value in for x. And so when I simplify this, what am I going to get? Well, I've got absolute value bars. What's 3 times -8? Minus 2 times what's -8 squared? See my point? And then I get -24 minus 128 inside absolute value bars, which is the absolute value of what does all this stuff become? -24 minus 128, so that's like what, -152? And then finally, what's the absolute value of -152?
152.
152. So anytime you're evaluating something, you're going to plug a value in. Before you even plug it in, just write the template without plugging it in. Just put parentheses wherever you used to have a variable, right? What if I did something then like that? Right? My input is x, my output is f of x. So if I want to do f of something other than an x, what's it going to equal? Well, it's just going to equal 5 times whatever my input is minus 9. Wherever I used to have an x, I'm just going to open up a set of parentheses. What am I plugging in?
-6r minus 1.
Yeah. Right? I'm plugging in -6r minus 1. And if I just do the math here, if I just distribute the 5, I'm going to get a -30r minus 5 minus 9, and I could just combine those like terms and I'm done. Right? So I end up with -30r minus 14 is my output. Right? So my input is -6r minus 1, and my output is -30r minus 14. It's a weird output because I've got a variable in there, but who cares? Right? That's what the function predicts. Okay? Real quick, there's some questions on here like this. These are so simple. Let me show you how easy these are. It says the function is graphed below. Based on the graph, f of 7 equals what? Well, this is so easy. All you got to do, look at this, super simple. If I just grab this vertical line, I'm going to go over to x equals 7. Everybody agree that's x equals 7? That's the input value. And where does it cross my function? When x equals 7, it intersects the function there. So that's the point that has an x value of 7. What's the y value? -4. So that's my answer. Right? Output, you see what I'm saying? The output value, when the input value is 7, the output value, which is the y value of the function, is just -4. Easy, right? What if I ask you one like this? What if I say, okay, same deal, you don't have to do anything, the graph is already provided for you. This time, based on the graph, solve the equation. F of x equals 2. Is 2 an input or an output number then?
Output.
Output, right? Because it's equal to f of x. F of x is the output. So it's asking, what's going to be the input value that's going to give me an output of 2, right? So I'm just looking for all of the places on my function where the output, which is x or y.
Output Y.
Output's y, right? Wherever the y is 2, those are the places I'm looking for. I want to know the input values. I want to know the x values where the output is 2. Well, where does that happen?
-10 and -2.
Everybody see that? There's a point right there that has a y coordinate of 2, and there's a point right there that has a y coordinate of 2. I want to know what the x coordinates are, though. Well, the x coordinate there is -10. The x coordinate there is -2, right? And so those are my answers. -10 and -2. Everybody see that? If I want to do that using Desmos, I mean, this is the same question, right? This is the very same question, only now they don't give me the graph. I just have to create the graph, but otherwise it's exactly the same. So all I have to do here is just use my Desmos graphing utility, which is embedded in the assignment, and I want to set this function right here. So that's my f of x. Everybody see this? Let me say one other thing. So this is like saying, when is this expression equal to -11? Everybody get that? So the function I'm using, it's like saying f of x, is the very same question as saying f of x equals -x² plus 2x minus 9. I want to know x equals what when f of x equals -11, right? So all I'd have to do is go into my graph and ask the question, where does the graph have a y value of -11? Well, let's graph the function and see. If I graph the function f of x equals -x² plus 2x minus 9, and then I want to know where is f of x equal to -11? Well, I'm just going to graph the line y equals -11 and look for the intersections. And there they are. I get an intersection there and an intersection there, right? So what are my x values if I round them to two places? I'm rounding them to the what? To the one place, and there's 10. -0.7 and 2.7. Everybody agree? So all I'm doing, and there's my trick. We talked about the other day. I can always solve any equation by graphing if I just graph the left side, and I could have set it equal to y. It doesn't have to be f of x. If I set y equal or f of x equal to the left side and y equal to the right side, and just look for the intersections, it's always going to give me the solutions, right? Those are the places where x is going to have that y value. Okay? Everybody see that? Great little trick. Y equals the left side, and I'll show you. Doesn't matter if it's even f of x. Might be easier just to even think about this as a y. I just want to know, where is that y value equal to that y value? Look for the intersections of the curves. Okay? All right. You can work. I'm going to take a picture of this to put it on the notes. But you can go to work and get questions answered, please. If you have anything, any